Notesheets out, Chris?
Yep. Feel a headache coming on.
Choir sounded great today.
Thank you.
I love the Irish Boss. That makes me cry every time. You guys do it. Okay, here we go. Tomorrow we're going to have a quiz. Or not tomorrow, whenever I see you again. We're going to have a quiz. And the quiz question could look just like this. You're going to have to sketch it. You're going to have to tell me what all the asymptotes are, what all the intercepts are, where all the holes are. So, what do we do to get this guy started? Factor it. We're going to factor it. So, it looks like on the top, I'm going to have a 2x and a 1x. I'm going to have a 3 and a 1. Alright, now I've taken a stab at that. There are no magic factoring pills. If you learned little tricks, you have forgotten them. The best way to do it is do what I did. Take a stab at it and then check. What do I get when I multiply the O's, the outsides? -6. The insides? Positive 1. Does -6 and positive 1 add up to what I need that middle term to be?
Mm-hmm.
Yep. So I guessed it right, and I'm ready to do the bottom. That one was a little easier. Okay? Now, what do you notice?
There's a hole.
There's a hole. So we're going to cancel that guy out, and we have 2x plus 1 over x minus 1. Is that yours? Okay, put it back on the desk. John, that's not how we behave. You know better than that. Now, John needs a pencil. Who will loan John a pencil? Otherwise, he has to buy one from me. And I'm sure there's someone in here that will loan him one. Emily?
John.
Or,
Quincy got it. John.
And he just stabbed his hand.
Quincy, that's very nice, but don't throw pencils.
That wasn't out of
Now he's in the hospital and
I don't care. Don't throw
serious
pencils.
situation. Why are you doing that?
throwing pencils. New stuff.
All right, is everybody okay to hear? So what happens now? Now we know we're going to have a hole, and on the quiz, you'll have to actually not only draw it, but you'll have to tell me where it is, okay? So where's it going to be? Look at what canceled out. Where's it going to be? Where x equals 3. Now, it's a hole. I'm going to have to plot it somewhere, so I need its y coordinate. How do I find its y coordinate? I plug 3 in right here, and what do I get when I plug in 3 for these x's? 7/2. So in the answer blank that says hole, I write 3, 7/2. And then on my graph, I plot the point 3, 7/2. Are everybody with me? Okay, what happens next? What do we need to, I mean, an order doesn't matter. I need to do something. What's something else that needs to be done? What? A vertical asymptote. Only one, and actually it's going to be at x equals 1. Because where do vertical asymptotes come from? What makes the denominator 0? Very, very good. So anything that makes the denominator 0 is going to be a vertical asymptote. So I have a vertical asymptote at 1. Okay. Now what? 2x over x will give me my horizontal asymptote. So my horizontal asymptote is where y equals 2. So there will be a blank that says, what's the horizontal asymptote? And you will write the equation y equals 2. And then you will step over to your graph and you will plot it, drawing that dashed line where y equals 2. Okay, what else? How about my intercepts? I need my intercepts. I need my x-intercepts and I need my y-intercepts. And how am I going to find those things?
0, -1/2 for the y.
So I let x be 0, so I'm going to put 0. Oh, that won't be that one though. I put 0 in for x to get my y-intercept. And when I put 0 in, what do I get on top? 1. What do I get on the bottom? -1. So my y-intercept is at 0, -1. To find the y-intercept, you're going to plug in 0. All right? Now, where does my x-intercept come from? It comes from the numerator. You're going to let y be 0. You're going to let y be 0. When you bring this guy over, he disappears because anything times 0 is still 0. So you end up solving the numerator. Subtract 1 divided by 2 is -1/2. So you have an x-intercept at -1/2, 0. X-intercepts come from the numerator. Now, at this point, you're kind of on your own now. You have to sketch it in. Can you visualize it? Have we done enough of these for you to visualize it? I think so. Remember, these 2 points right here have to be connected. Does this shape make sense to you, knowing that those 2 points there are connected? Now, that's only half the picture. Where's the other half? Up where the hole is. And can you visualize that looking like this? If you can't visualize that, then you're going to plot some points. You're going to set up a T-chart on your own, and you're going to say, okay, let x be 2, or 3, or 4. Plug them in, get those y coordinates so that you can plot some more points. Okay? Now we have looked at some weird graphs. The one on your quiz will be like this one. Alright, this is not a weird one. This is pretty standard. Right? You recognize that shape? Nothing tricky about it. All right, at the end of the period, we'll do a practice quiz. But that takes care of 2.6. 2.6 is done, and we're moving on to 2.7 now. So in terms of homework, you should now be able to finish your 2.6 assignment, okay?
So the next time you meet that quiz.
What? We're going to have to take a practice one today. Tomorrow we'll have an actual quiz. Thursday. But right now we're moving on to 2.7. We're going to get 2.7 done. Hopefully. Here we go. Now we're completely switching gears. This is not graphing. We're not doing any graphing. We are simply solving equations. So we're completely switching gears. Now, this involves fractions, so it's kind of like the graphs you just did, but you're not drawing a picture of this. We're not using a number line. We're not doing anything except x equals. All right? Now, anybody have a suggestion as to how we might make this problem a little easier on ourselves? Oh, Lord, look at him. Okay, we'll go with you, Deshani. I know, I can't help it.
Do we multiply each side by 4?
I would yes, that's what I would do. I would multiply everything by 4. Everything by 4. And the reason that I would do that, Emily, is why?
So you can get rid of the denominator.
Exactly. If you multiply everything by 4, then you no longer have fractions. Now, this is all that's left. The denominators have gone away, canceled out with the 4s, and all you have left is your numerators. Everybody can solve this equation. I got x equals 0 as my answer. Now, it is always easier to get rid of the fractions. I know you've had teachers in your past that say cute little things like fractions are our friends. But you know what? The reality is they make things harder. So we're just going to get rid of them if we can. All right, let's look at the next one. Now we're going to use the same exact strategy, but I'm not multiplying by 4 this time. What am I going to multiply by? X. So I am going to multiply everything by x. Everything gets times by x. And the reason you did it is so that would cancel out, right? So now we have, watch it here, x squared plus 2x equals 15. All right, you saw lots of those in your life. What do? Get it set equal to 0, so we're going to minus 15. And then, what are we going to try to do with it? We're going to try to factor it. Now, we know that not every equation factors, right? This one does, so we're all good. But what do we do if we encounter an equation like this that doesn't factor? We use the quadratic formula. Now, you could actually use it anyway on this problem if you wanted to. Now, this one does factor. But if you are not good at factoring and you don't want to factor, that's fine. Use the quadratic formula. You will get exactly the same answers, which are negative 5 and positive 3. Is that okay? Somebody have a question about that? All right, why don't you see, 3 looks a lot like the same thing. Why don't you see if you can do 3 on your own? 3 is just like 2. See if you can get an answer to problem number 3. You get started on, I'll do it up here, and then we'll compare our answers. And I need to take attendance. Looks like I'm missing Morgan. All right, how many of you got 3 or 4 as your answers? Now, anybody not understand? I did that kind of fast right there. Do I need to talk about any of that? Are we okay?
Does it matter if you just flip them?
What do you mean, flip them?
Like I subtracted negative 12 over x. Like I subtracted it to the other side, just did it in a different step.
Okay.
Did that change?
No, because didn't you ultimately end up with the same equation right here? Yeah. Yep. All right, now we got to go to 4, kids, and this is where it gets a little bit tougher. I want you to look closely at problem number 4 and tell me what you think might be a possible way to start it. Emily?
Were the 12 over x squared plus 4x, would you take out an x so it has x
Emily
plus
says, let's factor anything that factors. So, in this problem, the only thing that's factorable is that denominator right there. She says, I can take an x out of it, and that's what I did. So, in that regard, it's like your graphing questions that we did first. Start by factoring. If something factors, factor it. We didn't have anything to factor in these other problems. But if there is something, get it done. Okay, factor first. All right. Now, what could we multiply by that would get rid of all of the fractions? What? X plus 4 is part of it. What else would I have to multiply by? Besides x plus 4, I'd have to multiply by x. I need to multiply by both of these things in order to get that to cancel out. So I am going to multiply everything by x and x plus 4. Now notice, even though Mrs. Ford can do some of this in her head, she writes it down. Try not to be lazy. Write down what you're doing. You're timesing everything by the whole denominator because you want all this to cancel out, and won't it? So on that side, all we have is 12. Now over here, this first term was not even a fraction. So nothing cancels. This is going to be 2x squared plus 8x. Now, how did I do that? How did I get 2x squared plus 8x? I distributed. This is a multiplication. So I took 2x times x and 2x times 4. Here, that cancels, and what am I left with there? Minus 3x. Minus 3x. Oh my. What now? Combine like terms. So that would make 5x. And can I go ahead and bring my 12 over? Now, what are my options? If it factors, and this board's going to try to rig them so they factor, that's hard to do, I'll tell you right now. Let's see, I'm thinking in my head here. Maybe try 4 and 3. Now, that's trial and error. So I'm going to check. Pulse with P, you wait. Okay, so that gives me 8x minus 3x. Looks like I've got it. Okay, so what are my answers? Can you tell? X equals what? 3, not negative 3 halves, it's positive 3 halves. Or negative 4?
Let's go, let's go.
Actually, we're not ready to go just yet. We got a problem. I want you to look at this answer right here, negative 4. And I want you to put it back in the original problem. What happens if you put negative 4 back in the original problem? We get a 0 in the denominator, which...
So it's just 3 halves.
The answer is just 3 halves. What do we call that answer right there? We call that an extraneous root. an extraneous root. We talked about those before. Extraneous roots are roots that just we solve them. We haven't made any mistakes. They just don't work in the problem.
So should we always plug it back in?
Great, Miss Shani. Here's what you want to do though. All you really need to worry about is anything that's going to make this 0. So I'm not going to actually plug in 3/2 because there's no way 3/2 is going to make that 0. The only things that'll make it 0 are 0 and -4.
Okay.
So that's what I want to think about. Not so much plugging them back in, but right from the beginning, what values should I throw out? And it would be 0 and -4.
Thank you.
Great question. All right, let's turn the page. Oh boy, we got a bunch more. As soon as we finish these 3, we'll take a break. So let's get through these 3. Asia, how do you suggest we start this problem? Kind of a big problem. How do you suggest we start it? We're going to multiply by something, but before I'm sure what to multiply by, there's a step I have to do first. I got a factor, yep. I need to factor. I'm going to factor that guy right there. And how does he factor? Can anybody tell me?
X plus 4x minus 1.
Plus 4 minus 1. Very good. Which is very, very convenient. Right? Because that's what I got here. So I'm going to multiply everything by x plus 4, x minus 1. X plus 4, x minus 1, x plus 4, x minus 1. And I am not going to be lazy. I'm going to do that. I'm going to write that down. Now, Austin Kendrick, what did I do that for? What am I trying to accomplish here? I'm trying to cancel. So I'm going to cancel anything that'll cancel. See this guy right here? He's going to cancel. What am I left with? After I get rid of the part that cancels, what am I going to be left with? Do your distributive. What is it? 4x squared minus 4x. Right? Now, here, same thing, cancel. All right, so what's the left? Do your distributive. What is it? Plus 3x plus 12. Now, what about that side? The whole shebang canceled, so we are left with just 15. Uh-oh, now what? Now, let's collect like terms, clean this up a little bit. So that will make minus x. Let's bring this 15 over, and that would make it minus 3. What do we do now? Factor. Now, if you don't want to factor, you don't have to. You can use quadratic formula. I think this one does factor nicely. I gotta get my signs right, though. I need to be careful and get my signs right. Does that check? -4, +3, yep. what are my answers? X equals 7 equal to 0. You can't do it in your head. Write it down. What do you get? Negative 3/4. And what's the other one?
Positive
1. Here come the extraneous root radar, though. What about 1? Can't have it. That's an extraneous root. The two numbers that would not work are negative 4 and positive 1. If I get negative 4 or positive 1, I gotta throw them out. So the only answer to the problem is negative 3/4. Got it? All right, I'm gonna do one more and then you're on your own for that last one, okay? So let's see if we can get all our questions answered with this one. Step 1, Robbie Bridges. What am I gonna do first with problem number 6? Okay, because you've missed the first step. You're trying to do the right thing, but you've forgotten what I have to do first. Look back at the last problem. What was the very first thing we did? Does this guy factor? We can take out an x. So that's the first thing you want to do. Always factor first. Now that it's factored, Robbie, I know exactly what I need to multiply by, right? What do I need to multiply by? Exactly. So I'm going to multiply by x and x plus 1. X plus 1, x plus 1, and x plus 1. Now, some of you are going to forget to do this over here. And as long as that's a 0, it's no big deal, right? But if that's something else, you can't forget about it. Everything in the whole problem gets multiplied by x and x plus 1. Alright, so I did that so I could cancel. This x is going to cancel with that x, right? Oh, this is a little harder. Look what we're left with. What am I going to do here? I'm going to FOIL. These two have to be FOILed. So it's x squared plus x minus 3x minus 3. First, outside, inside, last. That's a FOIL. Now these cancel, and all I have left here is minus 3x, and here the whole mess cancels, and leaves me with plus 3 equal to 0. All right, Nancy, what do you want to do next? Yeah, let's clean it up. So we got an x squared. All right, how many x's do we have? A lot of them. Watch it. Some of them are positive and some are negative. So I think it'll be minus 5x. Oh, wait a minute. What happens to the 3's? It's gone. So that's what I'm left with after I clean everything up. What do you want to do with that? Factor. And when we say factor, we mean take out an x. That's all you can do. So what are your answers? You're ready to write your answers now. X equals what? 0 or 5? Beep, 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 beep. Go back to the beginning. Can x be 0? No. Throw it out. What is the other number x couldn't be? -1. I don't have to worry about that, I got 5. But in this problem, 0 and -1 are excluded values. They can't be used. So I got 0, I gotta throw it out. The only answer is 5. Okay? One more and we'll take a little break. I need you to do number 7. And I'm wondering if there's a volunteer who would come up and do it at the board while everybody else is working at his or her seat. It can be a team can come up. Okay, Gabby, anybody else want to come up? Help Gabby? I'm writing it for you. And if you need more room, we can erase this up. All right, everybody's busy working on your problem. Doesn't.
No.
I know, I'm sorry, it doesn't factor. It's hard to come up with problems like that where they end up factoring, and I did not do a good job on that one. But luckily, Gabby knew exactly what to do. Hopefully you did too. I could not have done that better myself, Gabby. Thank you for your good work. I'm going to show your canceling if that's okay, in case anybody has a question about where you got what you got.
A to B plus or minus B squared minus 4AC. Yeah.
Does anybody have a question about one of Gabby's steps? Notice, what did she do first? Factor. If something factors, kids, factor it. Same thing with the graph we're going to do in a little bit for practice. If something factors, you need to factor it. Okay? Any other issues? What would be the excluded values or the extraneous roots in this problem? Go back to the problem. What would be the numbers that we couldn't have as answers? Either -2 or +1. She didn't get those, so we don't need to worry about it. You okay? All right, we're going to take a quick break. While we take a break, this is what we're going to be doing. I need you to get your notebooks out or where